Hello everyone, and welcome to another simple science video where we aim to explain simple scientific concepts. And in this video, we are going to look at Newton's law of motion. Okay, let's get to it. Now let's start to get a view of what a force is. A force can be seen as a push or a pull, such as that of a tension in a wire or simply me pushing you. And force is defined as the rate of change of momentum. This is what you will be learning throughout physics or engineering. Force is the rate of change of momentum. And this helps us explain things like Newton's second law, which is very important. And we all know that force is a vector quantity. It has a magnitude and has a direction. Now let's look at Newton's first law of motion. It states that an object will remain at rest or moving at a constant velocity unless acted upon by a resultant force. This is based on the concept that if there's no resultant force, there is no acceleration. For example, look at the diagram. The truck on the top has no resultant force because there is no resultant force from the 100 minus the 100, so there's a zero resultant force, whilst the truck on the bottom has a resultant force of 40 newtons to the right. So therefore there is an acceleration in the direction of the resultant force of 40, there is a resultant force of 40 newtons in the right direction. So there must be an acceleration. Okay, now let's look at Newton's second law of motion. We know that Newton's second law of motion is very much based on the first law, and it states that the resultant force acting on an object is equal to the mass of that object multiplied by the acceleration of the object. And we can form the equation F equals ma. But at the start, I have defined force as the rate of change of momentum, or delta mv, or delta p, over t. And you can partialize this equation to give F equals m times delta v over t. And if we were to define each individual variable, you'd get force is equal to mass times by delta v over t. In other words, it's the rate of change of velocity. And since we've learned in the previous videos that the rate of change of velocity is acceleration, we have come up with force equals mass times acceleration. Okay? Now look at the following example. You're asked to find the acceleration. So the first thing you need to do is to find the resultant force, which is basically F. So that's 5 minus 2 gives you 3 newtons. And you can rearrange this equation to give you A equals F over m. And this, when you plug in all the values, you get 3 over 2, which gives you 1.5 meters per second squared. It should be to the left, but I didn't mention that. I forgot to. I'm sorry. Okay? Very simple. F equals ma is basically Newton's second law of motion. And an important application of Newton's second law of motion is understanding weight. As we know, force is mass times acceleration. Similarly, weight is mass times acceleration, but it's the acceleration of free fall, the acceleration of anything that gets dropped in a vacuum environment near the surface of Earth. That is W equals mg. And it works in this kind of model, as you can see I've drawn, where W, the weight, is equal to the mass of the object times by g, which is the acceleration of free fall. Okay, so what is, for example, the weight of a 5-kilogram ball on Earth? And we know that W equals mg, and g is about 9.8 near the surface of the Earth. So it is 5 kilograms times 9.8. It gives you 49 newtons. Okay, that is basically Newton's second law of motion, F equals ma. And Newton's third law of motion is, well, the hardest one to understand for a lot of people. And that is, for every force, there is an equal and opposite reaction force. So for every force, there is another twin force that is equal in magnitude but opposite in direction. And these two forces that I'm talking about, they must be forces of the same type. That means if the action force is a gravitational force, then the reaction force must also be a gravitational force. If the force is a push, no, I will explain it later. But they must be equal in magnitude and opposite in direction, and they must act on different objects. Okay, for example, looking at this diagram, this finger is pushing onto a wall. And if you were to learn at a atomic scale, the force in which the finger applies to the wall is an electromagnetic force between the electrons from the finger to the electrons of the wall. So let's just call it a electromagnetic force, or you'd like to call it an impulse force. So the force in which the finger applies onto the wall, the impulse force, should give you the same type in which the wall exerts onto the finger, which should be an impulse force, if that's the right word to use. But I'd recommend you to say that the force in which the finger pushes onto the wall is an electromagnetic force. Okay? And those two forces are the same type, so they are pairs, and they are equal and opposite. They are 5 newtons, and they're both 5 newtons, and they're in different directions. In opposite directions, and they act on different objects. Saying that the blue force is the finger acting on the wall. It's acting on the wall, and the green force is acting on the finger. Okay, so one is acting on the wall and one is acting on a finger. So they are different. They are acting on different objects. So if they obey these 3 rules, then they are action and reaction pairs, and these forces obey the third law of motion.